Good morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today's session we are going to handle about autoencoders. The autoencoders are a class of a neural network used for unsupervised learning, particularly in the realm of a dimensional reduction and the features learning. They work by compressing the input data into a lower dimensional representation and then reconstructing the original data from this representation. This process is achieved through an encoder decoder architecture where the encoder maps the input data to a latent space representation and the decoder reconstructs the original data from this representation. The three layers of autoencoders are the input layer, hidden layers, output layers. The input layer, this layer receives the input data which could be an image, text or any other form of data. The hidden layers where the latent space, the hidden layer represents a compressed lower dimensional representation of the input data. This layer captures the most important features of the input data. The output layer, this layer reconstructs the original input data from the latent space representation generated by the hidden layers. The types of autoencoders are under complete autoencoders, space autoencoders, constructive autoencoders, denoising autoencoders, convolutional autoencoders, variational autoencoders. The undercomplete autoencoders where these autoencoders are constrained in a way that the dimensional of the latent space representation is lower than that of the input data. This forced the model to learn the most essential features of the input data. The space autoencoders. In space autoencoders, the additional constraints are encomposed on the hidden layers of to have only a few active neurons at the time. This encourages the model to learn more efficient representation of the data. The constructive autoencoders where adds a penalty term to loss function, encouraging the model to learn a stable representation of the input data. This stability helps in handling a noisy input and improves the generalization. A denoising autoencoders where trying to reconstruct a clean data from a noisy input by corrupting the input data with noise, training the models to recover the original, denoising autoencoders learn a robust representation of the data. The convolutional autoencoders where uses the convolutional autoencoders are both in encoders and the decoders architecture, making them particularly effective for processing the spatial data such as image. They preserve the spatial structure of the input data during a comprehension and reconstruction. A vibrantly autoencoders or a probabilistic autoencoder that learns a latent space representation of the input data along with the associated probability distribution. This allows for generative and new data samples by sampling from the learned distribution, and in which we have a use case of autoencoders, a bidimensional reduction. The autoencoders are commonly used to reduce a dimensional of high dimensional data while preserving its important feature. This is useful for the data visualization and speeding up the subsequent machine learning algorithms. Anomaly detection. By learning a normal patterns in the data, autoencoders can detect anomalies or outliers that deviate significantly from the learned representation. The image compressions. A convolutional autoencoders in particularly are used for image processing compression application where reduction the size of the image while maintaining its quality is desired. A generative modeling, variation autoencoders are used for generative new data samples by sampling from the learned latent space distribution. This is useful in generating a realistic images, text and others. The basic properties of autoencoders were nonlinear feature learning. The autoencoders are capable of learning a nonlinear mapping between the input and the latent space, allowing them to capture a complex pattern in the data. Robustness to the noise, denoising the autoencoders and the other regularized the variants or robust to noisy input data, making them suitable for handling a real world data with imperfection. transfer at learning. A pre-trained autoencoders can be used as a feature extractor for a downstream task such as classification and the clustering, enabling the transfer learning in scenarios with the limited labeled data. Hence, we can also conclude that the autoencoders are a versatile neural network architecture with a various application in unsupervised learning, including a dimensional and reduction, anomaly detection, image compression, and generative modeling. With the different types of autoencoders tailored for the specific task and properties such as a nonlinear featured learning and robustness to noise. They continue to a valuable tools in the machine learning and artificial intelligence research and application. I hope you're clear with this concept. Thank you.